Hello, here we saw the demonstration of a robotic arm interacting with a human for our paper on permissive reactive robot task planning. For the experimental setup, we have the Franka robotic arm playing a block placing game with human on a shared grid. The robot can place or remove the blue blocks in any of the cell and the human can do the same with the red blocks in a turn-based manner. The grid on the right shows the current configuration during the simulation. And whenever the robot gives any feedback to human, for example place or remove a block, it shows up on the right grid. For example, here the feedback means that the human should remove the blocks from those highlighted cells. And here we consider the following LTL task for the robot, which says that repeatedly reach a state where no two occupied cells are adjacent and at least half of the cells are occupied. So it means it needs to repeatedly reach one of the following two configurations, and the robot is not aware of the task of the human. And for the first scenario, human wants to reach a state with one of the diagonals occupied. Our framework models this interaction as a two-player game as shown here. The circle state is robot state from where it chooses its action, and similarly from square state, human chooses its action. Now we show the video of our first experiments, which demonstrates the power of online adaptation of our framework. The game starts with robot placing a block. We can see that the robot is trying to reach the top target configuration. From this configuration, the game graph shows the three suitable actions for human for the robot to reach the top target. But the human here did not take those actions to meet its own target of forming a diagonal. So the robot here adapts its strategy to go towards the bottom target configuration instead. And from there on, both can play their strategy and finally reach a configuration that is consistent with both their tasks. For the second scenario, we'll now show the power of feedback with adaptability of our framework. Here the robot has the same task, but the human has no particular goal. Here again, robot initially is trying to reach the top target configuration. And since human again did not take the suitable action, the robot adapts towards the bottom target configuration. And now to reach the bottom target, human should take one of these two actions. But since human did not take them, the robot again adapts towards the top target. Now it's one step away from the top target, so the human should just remove the middle block to reach there. But the human did not do that and in total violated suitable actions thrice. So from now on, robot starts giving feedback. For example, here the robot advises human to remove the middle or the top right corner block. Now when the human starts listening to the feedback, the robot could finally reach the top target.